long story short, we end up with a generalized predictive model with a 3D distribution. So that model works pretty good with zero inflated data, because in the Long River survey, we have more than 85% of data are zero catch data. So, but in the original data set, these are not included. So we have to populate the zero catch data based on the sampling event. Yeah. And other than that, we have modeled year and gear as categorical variables, which means we do not assume any relationship for these two variables. And for other predictors, we just model them with smoothing functions as in the form of splines. And the interaction term were removed due to insignificant statistical results. Right, so here is a short glimpse of the calibration results using StrapSX as a result. So we have compared the design-based abundance indices here in blue and the model-based abundance indices here in red. So the design-based abundance indices is the kind of calculation we normally do for a random stratified survey, where we consider the weighting factor of different strata in different river region. So for the model-based abundance indices, as I said, it's basically by extracting the year effect from the model we developed. So by eyeballing, we see the two time series are generally synchronized in terms of the overall trend. But to go further, we kind of try to quantify the correlation between these two series using a Spearman correlation coefficients. So for the 9 case study here, they generally generate relative high correlation, which means trend-wise, we can trust the model-based indices can reflect very similar information compared to design-based indices. Okay, to sum this conclusion up, first of all, we found that through this comparison, the changes in Long River survey protocols, both in space and time, can really influence abundance indices, because it